This is STEM Junction's Girl Scout pneumatic robot arm. It's made out of cardboard from recycled Girl Scout cookie boxes and was used in Girl Scout STEM badges. It can be used to teach construction, pneumatics, principles of motion, all kinds of different things. Uses ordinary dispensing syringes with an additional connector for another syringe to move each of the muscles, and it's assembled using just zip ties. So very simple construction, no glue or other fasteners needed. Has a scoop style hand, and all the parts are cut on the laser cutter. This is our MUSE Laser Cutter here at STEM Junction. It uses a laser tube to generate laser energy that can be used to cut out materials. Your robot arms are made out of recycled boxes. These are Girl Scout cookie boxes. I created a design in CAD, computer-aided design, and then I've loaded it into Retina engraved software, which tells the laser what to do to cut out the parts. I've put a piece of the cardboard inside the laser, and I can run a bounding box to make sure that it's going to cut out inside of the material that I'm centered on the bed. And as you can see, the red dot stays inside of the piece of material, so this will work. The laser uses this industrial chiller to keep the laser tube cool. It circulates water through the tube. And we've got a fire extinguisher nearby just to be safe in case there's ever a fire. We also vent all the gases that the laser creates when it cuts outside through this tube. Next, I'll close the lid. We can still see through the lid, but it keeps the laser light from harming our eyes. It also holds in any smoke that's made when we cut. Next up, I'll hit start, and it will start the laser cutting. The laser itself is a robot. It has built-in controls that move this lens assembly on these gantry arms that move back and forth with these belts in order to trace out the same shape you saw on the computer screen. And that's amplified light, all one frequency, all focused, 45 watts, and that's able to cut through the cardboard, or it can cut through wood or plastic. This is the laser tube itself. That pink glow is the laser light, but it's all coming out this end and hitting a mirror assembly that shines the light through other mirrors on the gantry and then down to the cutting head. That black tube that you see on the side of the laser cutting head is actually an air tube. It blows air where it's cutting to blow the smoke out of the way, so there's nothing to impede the laser light, and 100% of its energy can be delivered to the spot that it's cutting. This machine is accurate to within 1/1000th of an inch. It can cut really small parts, can cut really fine details, and it can cut really close together. The material itself is sitting on this honeycomb, which is just a thin metal sheet made into a honeycomb, and that way smoke can go underneath it and be sucked out of the back, and also the laser won't cut the honeycomb because all the edges of it point straight up and there's not enough mass to heat up to burn away. The laser itself has a control panel on board with an e-stop. All equipment has a stop feature. In case something goes wrong, you can press that button and stop the laser from damaging itself or causing a fire. You can see the pink light inside the laser tube turn on and off when it moves the laser from place to place. See, it went off and back on as it moved. Cardboard's a great material to work with to prototype things, and you can get it for free because people get things in boxes and you can use those boxes. And you don't have to have a laser cutter to use it to prototype. You can cut it out with other tools, you just have to be careful. Of course, the laser can do a lot more precise job than a human being can do with their bare hands. Notice how when I designed this, I designed all the parts, but then I arrayed them on the panel so that we wouldn't waste a lot of material. We put as many parts on here as we could fit. That's called nesting. See how those parts fit closely together? That's nesting the parts together. And now we're done. So I can safely open up the lid and we can take a look at our parts. I'll pull out this, it's called a web. This is the bit that's left over. Here's the base plate for your robot. This is the webbing, that's the leftover bit that's not used. And really, if this was wood or something, we could even try to fit more smaller parts on areas of this that were left over. The goal is to waste as little material as possible. And a part like this is the usable part. This leftover piece is called a drop because it drops out when you're done. And even that could be used for something. So that's our laser cutter, and that's how we cut the parts out for your robot arm.